All right, section 4.3. You actually saw a little bit of section 4.3 right at the end of what we were doing in 4.2 when we went to the calculator and we ran that linear regression, or when we were in StatCrunch and we ran that linear regression and it had that screen that popped up with a whole lot of information. So we're going to be talking about all that information and what it means and how we work with that as statisticians, because in 4.3 we're all about the modeling. So what we want is we want to figure out what is the equation of the linear regression. Okay? What is the equation for that linear regression? Or when you were in algebra, we called this the best fit line. Okay? So we want to talk to you in terms of statistics, what that best fit line in algebra that you found before really means, okay? Because it's quite interesting on what it means and how it's really being found and what your calculator and what StatCrunch does behind the scenes. Again, I'm going to let StatCrunch or my calculator do the dirty work for me. I am not going to do this by hand. That's just crazy. Okay, so let's talk about modeling and in terms of what we call a regression line. Okay, the word regression, as it happens, regression means that it doesn't mean that we're going backwards, like we are regressing. Okay, regression means that it is trending towards the mean. Okay, it's moving towards the mean. That's what regression lines mean to us. Okay, and you're going to see all that information in that definition of moving towards the mean come to life in this. Okay, so regression lines, it does two things for us. It helps us predict future observations. Okay, and it summarizes a linear relationship. Okay, that regression line is like a summary of the scatter plot. Okay. Also, the regression line, whenever you find it using StatCrunch or our STA2023, this is the line, that is closest to all data points. It is the closest line to all data points. Okay. Our regression line looks like this: y equals a plus bx. Now, in algebra, you learned about this equation before. We called it slope-intercept, which was y equals mx plus b. This is the algebra form of the line, okay? In statistics, we switch these two guys around, okay? So A is really this B, that y-intercept. And the B that's here is representative of the M. So this is B plus MX. Now, if you look at our calculator, just so you know, our calculator under stat, and as you saw in 4.2, our calculator can do the algebra version, but what we want in the end is actually the linear regression version of at number 8. This is the statistician version. Okay, both of them will give you the same answer, just so you know, but 4 is really for the algebra and 8 is really for a statistician, or in stats class, as which you are in. Okay, so that kind of clears some things up there. All right, so let's jump out of that and let's talk about modeling some more. Okay, please know that when we deal with this equation, we do not actually use variables x and y. They are replaced with the names of the variables. Okay, so like when we were in 4.2 and we did at the very end people and trash, the way that we would put this in here is we would say trash equals whatever this number is, times people. Okay? We replace those with the variable names. We do not use X and Y. All right? Sometimes you will also see us put the word predicted in front of Y. So as I said, this was trash before. We might say this is predicted trash equals whatever A is plus B people. Okay? So know that we're not going to use these variables X and Y. We're going to actually use the names. And in StatCrunch, in that video from 4.2, if you actually go back and look at it, when we did the StatCrunch regression, you'd actually see in StatCrunch, it uses the names. It doesn't say X or Y. Okay? So that's about regression. And 4.3 is all about regression. Okay? And we're going to talk about what is it that this variable A, which is representative of the y-intercept, what it really means and how it's found. And what this variable B, which is representative of the slope, how it is found and what it means, because that's the next slide. So here is the math behind it. Okay? So in order to find the slope, or that variable B, you're going to take the correlation coefficient and you're going to multiply that by the standard deviation of y divided by the standard deviation of x. So you see why we don't really want to find this stuff by hand, because there's a lot going on here. Remember, this standard deviation formula is pretty huge, and running it by hand is just crazy, especially if you have a ton of points. Okay? But the way that we find the slope is we take the correlation coefficient, and we multiply it by the standard deviation of y divided by the standard deviation of x fraction. Okay? And then to get the intercept, what you're going to do is you're going to take the mean value of the y and subtract it from the slope times the mean value of the x. Okay? So the mean value of the y, that's y bar, which means mean value, subtracted from our slope times the mean value of the x. Okay? That's how these are found. That's the math. Again, you're not going to be doing this by hand. This is what our calculator and what StatCrunch are doing behind the scenes. They have programs for this, so that way you are not doing this. Okay? All right. So let's talk about some extra information and what all this means to us. Okay? So x variable, the y variable, so those x and y's that we were talking about over here, they have different names, just so you know. So the x variable, we call it the predictor, explanatory, or the independent variable, which makes sense, being independent. So the x variable is called the predictor, explanatory, or the independent variable. The y variable is called the predicted, hence why we put predicted in front of y. The response, or the dependent. Okay? So these are all names that we can use in place of saying x variable, y variable. So we can talk about who is the predictor, who is the predicted, who is the explanatory, who is the response, or who is the independent versus who is the dependent. Okay? Now, please know that in this one, when you are finding the regression line, the order of your variables matter. Okay? So as I was talking about in 4.2, in 4.2, you can switch the two variables, and that does not change the correlation coefficient. But in here, when you're looking for the lines, okay, the regression line, if you switch the variables, that changes the line. Okay? It doesn't change the correlation coefficient, it changes the line. And I'll show you that here in a problem or two, okay? So in this one, it's very important that you keep the order. Whoever's supposed to be the predictor needs to stay. Whoever's the predicted needs to stay. Because if I switch those two, I have a whole new line that I'm looking at. Now the correlation coefficient is still the same again, but the line is different if you switch them. Okay. Okay, so right here, the regression line represents the points that are the mean value of the variable at each value of the x variable. So what's that saying is where that line comes from, where the line comes from in our regression. Remember in 4.2 when I showed you the scatter plot on StatCrunch, how it gave you that red line in there? That red line, it means every point on that red line. That's what this is saying. Every point on that red line is the value of x, comma, the mean value of the y variable at that point. Okay? So it is the mean value of the y variable at that x value. Okay? Again, I'll explain this here in just a second when we get to it. So what this sentence right here is, it's about all those points that form that red line that was in StatCrunch that we saw in 4.2. Okay? That every point on there is the x value, comma, the mean value of the y at that number. All right? Down here, this explains what slope and intercepts are. Slope, when you were talking about slope, it compares the mean value of the y variable for objects that are 1 unit apart on the x variable. Okay? I'm going to talk about this more in terms of a problem. So this will make sense when we talk about it in terms of a problem, I promise. Okay? But know that the slope compares the mean value of the y variable for objects that are 1 unit apart on the x variable. Okay? So, another piece that you should know, when the slope is 0, there is no association. There's no trend, which again, the R value should show this as well, because the R value should be close to 0. Okay? So when your R value is close to 0, the slope is really, 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 really close to 0. Okay? All right. And last but not least, the intercept is the predicted mean y value when x is 0. Okay? So when x is 0, this is going to be the mean y value of the data when x is 0. Whenever you're dealing with the intercept, you should always ask yourself if it makes sense. Okay? Because some intercepts just don't make any sense when it comes to the regression model. All right? Again, I will have a problem that helps explain this a little bit more. Okay, I know these last few pieces seem really weird where it says it's the mean value of the y variable at each value of the x variable, things like that. I'm going to explain that a little bit more as we get into a problem. But these are things that you should know. This is what it really is talking about, okay, and what it means. All right, so here's what's going to happen in your homework. So let's do some problems and let's work through some things, okay? So this problem has lots of information. It's asking you to interpret the slope and other things like that. So when we look at this, it says the graph shows the height of mothers and daughters, okay? So here's that trend line that we were talking about. This is the regression line. Here is the equation they gave us. Sometimes you will see the word predicted in front of this. Sometimes you won't, okay? But here's the intercept. Here is the slope. All right? So down below here, as the data are graphed, which is the independent variable and which is the dependent variable? Hopefully you know this, but pause the video, take a moment, and if you actually want to answer these questions, let me give you the full page. Let me go ahead and give this to you. Go ahead, pause the video, give it a shot. You can do all this information based off of what you know. Okay? And go. Okay. So, This example is going to help me explain everything that we talked about from the second dot on down. Okay? I'm going to be able to explain all that right here. So the first one's easy. Who is the independent variable? And that's mom. Okay? I don't know why I did that. Mom is the independent. The x-axis is the independent. The number or the word that is by the number is the independent, always. Okay? The dependent then, obviously, is daughter. Or the y-axis. The y-axis is always the dependent. Fix that D. There we go. All right, so now, part B says, from the graph, approximate the height of the daughter of a mother who is 60 inches tall. So a mother is 60. They want to know how tall is the daughter. So there's 60. And then kind of drawn across as best as I can. That's horrible. Let's redo that. I have a straight line tool. I'm just not using it. I don't know why, because I'm an idiot. So drawing straight across as best as I can. That's a little bit better. So what do you think this value is right there? And that predicted height of the daughter looks to be, I'd probably say about 663. Okay, that's what they want you to do. And then down here, it says from the equation, determine the predicted height. So they actually want you to take the 60 now and plug it into the equation up here. Okay? So that's what part C is all about. So the daughter equals 29.92 plus 0.5417 times 60. So we just go to our calculator and we put that in. 29.92 plus 0.5417, 0.5417, and 60. Hit enter. And it says it's 62.422. So we are a little high, but we're darn close. Okay? It probably says to round to the nearest whole number. So obviously we would say that this is 62 inches. Okay? So notice that our guess, because we were looking at the graph, and then what our equation gave us, pretty darn close. Okay? So let me go back, and now let me talk to you about what you're looking at here. So that means that the point 60, comma, and then this guy was like 62.4. Let me explain. That means that this point right here is on that red line. Okay? That's this guy that's right there. What this means is that at the value of 60, this is the mean y value at that point. Okay? That's what I was talking about here. The linear regression line represents points that are the mean y value, okay, are the mean value of the y variable at each value. So at the value 60, this is the mean y value. So it took all these points that happened at 60 and it found the mean y value for it. And that would be it. Okay? So all these daughters' heights that happened at 60, the mean y, or all these daughters' heights who had a mother that was 60 inches, the mean value between all of them is 62.4 inches. Okay? I hope that makes a little bit more sense of what this means. So all these points that are on here at this value, at this mother's height, this was the mean value for all the Y values that were there. Okay? At 65, right here, it looks like this guy is probably about at 65 too. So if your mother is 65 inches tall, then the mean value of all the girls that we looked at was also 65. Okay? Now, let's talk about the next piece, because the next one says interpret the slope. So the slope says that it compares the mean values of the Y variable for objects that are 1 unit apart on the X variable. So when I interpret the slope is right here. That's the slope. So what this means is that as my mother increases by 1 inch in height, as your mother increases by 1 inch in height, by 1 unit apart, okay, your daughter's height will increase by 0.5417 inches. That's what this means right there for the slope. Okay? As your mother's height increases by 1 inch, the average height for your daughter will increase by 0.5417 inches. The mean value, the average increase for every inch is that. Okay? That's what the slope means. So up here, this is the average increase for every inch your mother grows. Okay? So that's the interpretation of the slope. Now, the other thing you can think about this is that, again, this is where we go back, the intercept. So the intercept, went back too far, is right here. So what this means is if your mother's height is 0, because intercept is when the X value is 0. So if your mother is 0 inches high, that means your daughter will be, on average, because it's an average again, it's all about the mean Y value. The average height of your daughter will be 29.92 inches. Does that make sense? No, that does not make sense. Even though that's not a question on here, I wanted to talk about that real quick because this is a great illustration of that. That does not make sense. If your mother is 0 inches high, that means your mother doesn't even exist. Okay? So if your mother doesn't exist, that means you as a daughter, you're 29.92 inches tall. That makes no sense. Because if your mother doesn't exist, the daughter doesn't exist. So this is where, even though, yes, it gives you an intercept, you should always ask yourself, does it make sense? And in this case, it doesn't make sense in here, this 29.92. All right. But now, part E says, what other factors besides the mother's height might influence your daughter's height? Because obviously, the height of your mother does not tell you the height of the daughter. Okay? What other factors might influence this? And again, this is a multiple choice question. All of these, other than, the top 3 are not going to be multiple choice, but D and E will be multiple choice. Down here, you're going to be looking for something that makes sense in the multiple choice. And there are lots of things that are going to affect your daughter's height. Okay? Are they taking vitamins and growth hormones? Are they well fed? Okay? There are lots of things that affect the daughter's height. What is the height of the husband? or the height of the father. Okay. Some of your genes play a factor into that. It's not just the mother's height alone that tells you the daughter's height. Again, just because we kind of see a correlation here does not mean causation. Just because your mom is short doesn't mean you're going to be short. Just because your mom is tall doesn't mean you're going to be tall. Okay. So that's what this question E is asking about. All right. Let's do it again. So take this one. Go ahead. Pause the video and tell me about what you know. Go. Okay, so this question right here is a lot like what we just did in the previous question with B and C. Okay? So the scatter plot shows the median annual pay for college-educated men and women in 50 states in 2005, according to the U.S. Census Bureau. The correlation is 0.834. The regression equation is given there above the graph, so you can see it. This time they actually put in the word predicted. Okay? So part A says, find a rough estimate of the median pay for women in a state that has the median pay of about 600 for men. So hopefully you kind of, what they're hoping you do is you kind of draw in like a little line right here. So I think that's where the line is. Sorry, my computer moved at the end there. I think there's your line. So they're asking, what happens to women at 60,000 for men? What is the average woman's pay? So if we kind of go over a little bit, honestly, it looks like it's right there at 45,000. Okay? That would be the average median pay for women if men make $60,000. Part B says, plug it in. See if that really is a close prediction that you made. So women equals 8,707 plus 0.5932 times 60,000. Okay? So we go to our calculator. 8,707 plus, it is 707, right? Yep. 0.5932. 0.5932. And then 60,000. Hit enter. I was close, a little bit over. So 44,299. So 44,299. And there you go. That's all they wanted. Make a prediction using the graph, make a prediction using the equation. And again, these are just predictions based off of averages, means. Okay? All right, so this one, they've given us information. Okay? See if you can read this information and answer the questions below. And go. Okay. So below it says we got a computer output shown below is for predicted foot length from hand length. Okay? In centimeters for a group of women. So they're thinking that if you know the hand length, we can predict the foot length for women. Assume the trend is linear. Good, because if it wasn't linear, we wouldn't be doing this. And then we're going to answer the questions. So it says report the regression equation using the words hand and foot. So notice the equation they gave us up here is in the variable y and the variable x. All they want you to do is rewrite it with the words hand and foot. So if I rewrite this, the y is all about the foot. So we'll call it foot equals, or you might put the word predicted foot equals 5.67 plus 0.998. X is hand. So I put it in parentheses, but you don't really have to have it in parentheses. So that's what they want for part A. Part B says they want you to verify this number. They're asking about the slope. Can you verify that it is 0.998? So all we're going to do is plug into this formula the numbers that we know. Okay, let's do this in a different color. So let's grab blue. So what is the R value? Okay, that's R. R is the correlation coefficient. So it is 0.948. This is the standard deviation of the Y value. Standard deviation of the Y value is 1.230 over standard deviation of the X. That's 1.168. Sorry, I missed another one. 168. All we have to do is just go and multiply these in the calculator and see that that's what comes out. So this was the R. This was your SX. This was your SY. Okay, they're just seeing if you can interpret and read information. So if we go to our calculator, 0.948. Okay, and then alpha y equals, oh, sorry. Nope, we don't want that yet. So we're going to multiply by the fraction alpha y equals, and it is 1.23 over 1.168. So 1.230 over 1.168. And yes, that verifies that the slope is 0.998. And you can see it 0.998. Down here, they're going to do the same thing. They just want to make sure that you can grab the information and plug it in. So in this guy right here, they want you to verify this number. So all you're going to do is plug in the mean for the Y, which is this guy, 23.318, minus your slope, which you already just found and verified. That's this guy. That's the B. Okay. So 0.998. And we're going to multiply that by the mean of the X, which is right there. So 17.682. So let's go to our calculator and let's do this. So the first guy was 23.318. 3.318 minus, I'm going to go up here and grab this number because that really is our slope. And we're going to multiply that by 17.682. 682. I like to try and be as accurate as possible. That's why I grabbed that number instead of just doing 0.998, because I don't want to use a rounded answer and then have to round again. Again, your guys' calculators are going to be accurate, okay? And there you go, 5.6656. Did that match? 5.665, and the 5 says, hey, 6 round up. So yes, it does match. It's good. Okay? And then last but not least, I just wanted you to plug in. Use the regression equation and predict someone who has a hand length of 18 centimeters. So all we're going to do is take 5.67 plus 0.998 times 18 and see what we get. That's all they want us to do. So going over to our calculator, 5.67 plus 0.998 times 18. I know I've got an extra 0 in front. It shouldn't matter, but I'm going to go over there and delete one of those out. There we go. And there it is, 23.634. Again, I don't know what they want us to round to. So 23 point, what did I say, 634? Yeah, 634 centimeters. And there we go. Okay. Nothing crazy. It's just all about, can you plug into these formulas? And in your assignment, they're going to have you plug in those numbers. That's why I kind of labeled them up here. That's where these numbers would actually go into a blank on your assignment. So you're actually filling stuff in when you do these. Okay. So this isn't much of a multiple choice. This is, do you know which numbers that you should be putting where? Okay. All right. So I'm going to zoom in on this one. But what you're looking at here, there is the scatter plot. And then down here are 3 versions of the information for the linear regression taken from different things. Like this is from a stat application called Minitab. This one right here is from StatCrunch, which you've seen before. This one is from Excel, because actually the cool thing is everything that we've been talking about, Excel can do. I'm just staying away from it because we have our calculator and we have StatCrunch, which StatCrunch is amazing. So that's why I'm not talking about Excel. But if you play around in Excel, you can do everything that we talk about. Everything from chapter 2 and chapter 3, all in Excel. Excel can do it. Okay, so this is information from Excel. And then down here, this is the TI-84 information that we've seen before. Okay, so I'm going to zoom in on this. So what it wants, okay, so it says measurements were made for a sample of adult men. A regression line was fit to predict the men's arm span from their height. Because a lot of people say that your arm span should match your height, okay? The span of your arms from fingertip to fingertip should match how tall you are. Kind of interesting. So they're kind of putting that to the test here. Okay, and the outputs from several technologies, so as I talked about, Minitab, Excel, StatCrunch, and our TI-84 are provided. So they want us to, part A, report the equation for predicting arm span from the height, okay? And use arm span and not just X and Y. So based off this information down here, can you tell me the equation of our regression line? Okay. So let me kind of bring this information up. Actually, looking at this information, go ahead, pause the video and tell me the equation based off of what you're seeing right here. Okay. So if you're looking at these things, obviously from Minitab, there's the equation. Okay. Although Minitab does a little bit more rounding. From StatCrunch, again, right here is the equation. And it has the words and everything in its spot. All right. It doesn't do as much rounding. Also, it tells you a little bit more. The sample size. There's our correlation coefficient. There's R squared, which we will talk about in 4.4. And then there's an estimate of error, which, again, we'll talk about later on. Okay? But I gave you these two, and I left it on these two because I want to make sure that you understand what you're looking at here. Okay? We already know that the y-axis is all about the arm span, and the x-axis is all about height. So we know that when we write this, our equation is predicted arm span equals something, 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 and then over here it's going to be height. Okay? So let's plug in what we have over here. And I wanted to give you these so that way you understand everything. So obviously down here, that you can recognize the A and the B as in the stat equation. Okay? But just remember down here, the A represents the intercept, the B represents the slope. Okay? And up here, when you look at this, I know this is stated weird, but this right here, it says X variable. This guy is the slope. And then obviously this is the intercept right above it. Okay? So if we write our equation, and let's go ahead and keep this to the nearest hundredth. I'm not sure what they will have you guys do. But again, read that fine print on the rounding. So if we go to the nearest hundredth, the intercept is, the 8 says, hey, 0, go up. So 6.241. Plus, and it's a plus because our slope is positive. If this slope was negative, we would have put minus. Okay? So plus, this guy rounded to the nearest hundredth. The 6 says, hey, 4, go up. So 2.515. There's the regression equation. And again, it matches everything that we saw right up here. Oh, look, arm span, 2.641 plus 2.515. Height. Okay? And matches the same thing from Minitab. All right? So there's part A. Part B says report the slope and the intercept. So in other words, what they want you to do is tell us what the slope and the intercept are, and then tell us what they mean. Okay? Well, again, all of these, we got all the information. Here is the intercept. Here is the slope. Okay? If we're looking up here, here is the intercept. Here is the slope. Okay? Down below, obviously, we've got it already labeled for you guys. So let's talk about in terms of what does the intercept and the slope mean. All right. So the slope. Okay? So what this means is, looking at this data, for every inch you get in height, your arm span increases at an average, because this is a mean, remember, of an average of 2.515 centimeters. Okay? So, as you increase by 1 inch, 1 unit in height, on average, your arm span will increase by 2.51 centimeters. That's what that slope means. The intercept, if your height is 0, then you have an arm span of 6.2 centimeters. Does that even make sense? No. Because if your height is 0, that means you do not exist. And if you do not exist, you do not have an arm span. Okay? So we can report the intercept, but then down below when it says interpret, you would say this is nonsense. This doesn't make any sense. Okay? And there you go. All right. I think this might be the last question. Let me double check. Nope. How many more questions we got? Looks like 3 more. Yeah. Okay. So in this one, it says indicate which variable you think should be the predictor and which variable is the response. And then explain your choices. So it says you collect data on the number of gallons of gas it takes to fill up the tank after driving a certain number of miles. Okay? You wish to know how many miles you've driven based on the number of gallons it took to fill up. Okay? So it's this last sentence that tells me everything you need to know. Go ahead and pause the video and see if you know who is the predictor and who is the response. Go. Okay, so we got two ideas here. We've got gas, which is in gallons, and we've got miles, technically driven. I don't know why I said mild. Miles driven. Based off this last sentence, if you read this, it says, you wish to know how many miles you've driven based on the number of gallons it took to fill up the tank. Okay? So with that information, it's saying that you're going to know the number of gallons, and they want to know how many miles you drove. So that right there is telling me that gallons is your predictor. You're going to know the number of gallons to begin with. And they're going to use that number of gallons to predict I don't know why I put predictor. That's weird. Predictor. Okay? And then this is going to be your response. I don't know why they're mixing and matching those names. Or this should be the predicted. Okay? So, knowing the number of gallons you filled in, you can plug it into this equation, and it will tell you how many miles you have driven. The response. That's how I know. Because you're going to be given the gas. And they're going to say, all right, how far have you drove? Okay? There we go. That's all they want in that. It's a simple, kind of drop down question when you get to it. I skipped over a problem. I know that's not there. Actually, did I not go back far enough? Did we do this one? No. So let's jump back to this guy. Go ahead, pause your video, give this one a shot. Think about it. Nothing crazy going on here. All right, so it says the figure shows the scatter plot of the last two digits of some students' social security numbers and their ages. Okay, so down here is their ages, and then over here, this is the last two digits. They're seeing if there's a relationship. So it says, if a linear regression line was drawn, would it be positive, negative, or near zero? So hopefully on this thing, you said near zero, because there really is no trend here. This is just a bunch of smattering. I mean, it kind of looks like everything. It's just a smattering, plain and simple. Okay. There's no pattern here, because when you're in your 20s, the last two digits look like they could have been anything. When you're in your, around 25, the last two digits could have been anything. Okay. And it looks like we have a lot of information about the younger ages than we did for the 50s and 45s and 40s. Okay. So, but this has no trend. So based off of that information, give an estimate of the numerical value of the correlation between the age and the Social Security. So remember, we talked about that. If there is no trend, then the correlation coefficient should also be near zero. Okay? If the linear regression line has a slope near zero, then so is the correlation coefficient near zero. Okay? And then last but not least, explain what this graph tells us about the relation between Social Security number and age. And it tells us nothing. There is no association between the last two digits of the Social Security number and your age. Okay? There is no association. There we go. All right, last problem. Stat crunch and calculator time. Okay, so what I have given you here, I don't think this is very big. Okay, good. So what we have here is the table shows the number of text messages sent and received by some people in one day. Okay, so they want you to make a scatter plot and state the sign of the slope from the scatter plot. Okay, use the numbers sent as the independent, which makes sense because the first column is usually X, the second column is usually Y. So I'm going to do the calculator first. So we're going to put in all this information and we're going to make a scatter plot because again, I showed you the scatter plot. But again, in this one, I like using StatCrunch. I think it's more handy and user-friendly. So we're going to come in here. Oh, I got data from 4.2 in here. So let's clear that out and hit enter. Go over here and clear that out and hit enter. And let's start putting in our data. So we got 1, 1. How many did it say we have? Oh, it didn't. So let's count this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 20 total. Okay, that's what I figured it was. So 11055. All right, so 1, 1, 0, 5, 5. Oops. 5, 5, and then I remember the next one was 50. Then after that, we've got 6, 5, 330. 6, 5, 330. So there's our first column. Let's go to the next column. 10, 3, 2, 5. Okay. Oops. So 10, 3, 2, 5. And then we have 0 to 201. 0 to 201. And finally, 150. 150. Notice that I'm on number 20, so I know that I've gotten everybody. Okay, so let's go back over here to list 2. And we got 21051. 21051. And then we've got 75, 8, 7, 300. 75, 8, I forgot. 7, 300. 7, 300. And then I think it was 10 below, nope, 40 below that. So there's our first 10. Ooh, not 400. Next column, we've got 10. Oh, man. Did I do? No, I did it right. Okay. I think. So it's pretty much matches the number that's right across from it. The only difference is this 3 is actually a 5. Everybody else matches. Okay. So that's easy to do. So that's 10. The 3 is actually a 5 this time. And then everybody else matches from here on out. 5, 0, 2, 200, 1, 150. And there we go. Just want to double check on that. Yes. Okay. So now, remember in 4.2, I showed you where to go. So we're just going to do that same thing again. We're going to go back into stat. Okay. And you can go over to, well, actually, sorry, I'm jumping ahead of myself. We need a graph first. So I showed you what to do with that. Hit second, y equals. Make sure stat plot 1 is on, and it's all set. So we're going to hit zoom. And then you're going to scroll down to number 9 to make sure that it accompanies all the information. Okay, so you hit enter. Sorry, I went too far. I think I hit zoom fit. We want zoom stat. Yeah, I did. So here's what it looks like. Again, that's really, really ugly. Okay, but it's good enough to help us answer the question that it's asking. All right. But I want to go into StatCrunch and put that information in. So yes, I got to put that information in again. So we're going to call this guy, this is sent, and this is the received. Okay, sent, receive. Let's put those numbers in this guy. So 1105550. So this should hopefully be a little bit faster. 1105550. So 1105550, 330. Oh, I keep pushing the wrong thing. So 300, jumping over my screen, 330. So there's the first 10. And then we've got 103250. 103250. And 200, 150. I keep pushing the wrong stuff. Move that. 10. I've already forgotten my numbers. 200, 150. 200, 100, and there we go, 20. Yeah. So the other side, 21051. So 2101. Losing my numbers. Having a brain meltdown. 21051. 21051. There we go. Now we're back on track. 7587 340. 7587 340. Okay. Yes. And then over here, the one that changed was the 3 and everybody else matched. Okay. So this guy is a 5 and everybody else matches the one that's beside them. 2, 5, 0, 2, 200, 1, 150. And then so now we can go into stat. And right here, this is actually just going to give us all the information. Once we say that X is sent and Y is receive. And there is an even better picture than what our calculator gave us. Okay? So if we look at this, we definitely see, and we saw on the calculator, that there definitely looks to be a regression here, and it is increasing from left to right. So that means that it will be a positive slope. Okay? So in here, state the sign of it, it will be positive, and then you saw what the scatter plot looked like. Okay? So part A is all done. Now find the linear regression. Well, in the calculator, you'll go to Stat, Calculate, and you'll scroll down to number 8, just like what we did in 4.2. Hit Enter, and hit Enter all the way down, or just scroll down and then hit Enter. And here's all the information. Here is the intercept. Here is the slope. Here is the coefficient, the correlation coefficient. Okay, so you can see that it's it's not pretty, it's really, really strong. Okay, really, really strong. So what do they want us to do? They want us to write the linear regression. Okay, and it says graph the line with the technology. Well, if you are doing this in the The calculator, you can do this. I think it's a little bit cumbersome to do this. Okay. I like doing it in StatCrunch because, again, in StatCrunch, oh, look, it's already done. Oh, look, if you hover over it, there's the equation. You just got to put in what the y and the x stand for. Okay. But if you already go back to this page, look right up here. All that information that you've seen before. Receive equals, there's those numbers, and sent. It's already there for you. You just got to write out the answer. Okay? So we've got receive equals, let's round to the nearest thousandth, so 3 decimal places. So 1.872. Okay. So we've got receive equals 1.872 plus, okay, let's go back. Let's look at our StatCrunch. Rounded to the nearest hundredth would be 1.001 cent. Okay. 1.001 cent. There's our equation. And now you know what C and D are all about. So interpret this information. Okay? So the slope means that every time I send a text, on average, I will receive 1 text. Well, that makes sense. If you send something out, hopefully you'll get a reply back. So that's what this means. Every time I send a text, that's your X. Every time I increase by 1 text, I will receive on average 1 text. Okay? Interpretation of the intercept. If I do not send a text, on average, I get about 2 texts. Now that makes sense. Because people want to talk to me. I'm popular. I'm Mr. Armstrong. Who wouldn't want to talk to Mr. Armstrong? So this is one of those where the intercept does make sense. Do I have to send text to receive text? Absolutely not. Okay? So this intercept makes sense, and it means that if I don't send any texts, on average, I receive 1.8 texts. You really don't have 0.8 of a text. So that means on average, I receive about 2 texts. Okay? And there you go. That's what 4.3 is all about. Finding that model and knowing what it means. Okay? So questions for 4.3 happen from question 24 through 45. All right. I will catch you next time, my little statisticians.